Bryce, you might want to scooch to your left. Get out of your comfort zone. Talk to Ethan. Yeah, graph. Ethan, talk to me. What do you do?
I just move the locator point up and down on X equals Y. X equals 4. Any Y value is going to get the X value in 4.
Agreed? There's X's, there's Y's. You okay with that? Anybody got a different way to graph X equals 4? Different kind of graph? What other kind of graph can we graph numbers on? Let me ask the question differently. Do we need the y-axis, since as Ethan told us, the y doesn't change, it doesn't matter what the y is? So what if we just got rid of the y-axis? What would this graph look like?
A line.
What kind of line?
Like a line graph. It's a horizontal line.
Oh, yeah. Guys, do we agree that that's x equals 4? There's only one variable, right? So we really only need one line. We only need one axis to graph one variable. All right. I want you to graph go. Graph that. Liz, how are you gonna graph x plus 2y equals 6? Now what? Now what? Could I graph this without the second axis, the y-axis? No, one variable only needs one axis, two variables needs two axes. Discuss with your partner how you might graph that equation.
Like the fourth dimension?
Or possibly the third.
Sorry. Z is like out this way. Set like a diagonal. You know what? Origami.
Hey, by the way, you don't have to graph it, you just have to talk about how you might graph it. Gwenny, what do you guys think?
It like comes out. Okay. It's like. Yeah.
Third axis.
Oh, wow.
So it's like isn't Z like the diagonal?
It looks to me like it's just coming straight out of the board.
Oh, I don't like that.
We got our x-axis, we got our y-axis, they're perpendicular to each other. And we got our z-axis coming out.
Then what's the other axis?
Which other axis?
The one that would be on the back of the board.
Well, that would be, good question. What's the axis that goes through into Mr. Schick's room? Negative z. Here's our positive numbers, and then there's our negative numbers. Yeah. Yeah. So what we're going to be doing for the next few days is we're going to talk about three-dimensional graphing. Because if you think about it, you started out and you learn numbers. And they taught you number lines. And you just learn numbers. And then later on, when you got to little pre-algebra and then lots into algebra and then all through into algebra 2, we did lots of things with two variables. Remember the xylophone players and the yodelers going up the mountain in the algebra book?
No,
Yeah, there was a problem with xylophone players and yodelers, and they had to pay different amounts to go up the mountain in the cable car so that they could play their xylophones and yodel at the top of the mountain. You ever wonder why it was xylophone players and yodelers?
X and Y.
X and Y, exactly. But we've done lots and lots of problems over the years, and our problems always had two variables. You made caramels, you made taffies. Why is that even out? Put it in your bag,
Okay.
off, please. In my class, in your bag, not your pocket. I shouldn't have to keep telling people this. Caramels and taffies. Brownies and cookies. We've had problem after problem after problem where you've got two things happening. Crawlers and rovers. I want to make two different kinds of off-road vehicles. Well, what do you do if you want to make three different kinds of off-road vehicles? What do you do if you want to make three kinds of candies? What do you do if the xylophone players and the yodelers are getting ready to go up the mountain and all of a sudden a bunch of zither players show up and say, hey, can we go with you? Zither, yes, it's a thing. Starts with a Z. It's a thing that starts with a Z. So now all of a sudden, you've got 3 variables, 3 unknowns. Now, here's the other thing. Why did we start with 1 number and then go to 2 numbers? Well, because you needed to know about 1 number before you could process the idea of 2 different numbers. You could also graph it on a piece of paper. But guess what? Look around you. What do you notice? Life is 3-dimensional. Can you imagine if I was stuck just going either this way or that way or up or down? I couldn't get very far, could I? If the Egyptian. How does that work? I'm not very good at this stuff. But in real life, I can also walk forward and backwards. Real life is 3-dimensional. So we're going to play around a little bit. Each pair of you is going to need scissors. And I've got a little thing for you to cut out. You are going to cut all the way around the outside of this shape. The outside of this shape. You're going to have a big, square, blocky L. Get scissors and cut it. Go. You will also need tape. Guess if I told you need tape before, you won't get make one cut. Cut it out all the way around the outside. All the way around the outside. Yeah? No. You're going to work together. You're a pair. But I'm going to cut one out as well. Corbin, can I have your phone, please? Sure. Oh, don't throw it. Oh. What? No. Oh, yeah. You know what makes cutting much easier? Normal size scissors. These are annoying.
They're better than the alternative, smaller.
Yeah, the really, really tiny ones are even more annoying. But nothing, because I haven't told you yet. No, don't ask.
I'm telling you. Telling you what to do.
All right. Got it cut yet? Almost everybody. I want you to fold it along the 2 axes. Fold it along the axes. I want you to fold it so that the grids are inside. Fold it along the axes so that the grids are inside. Inside, Andrew. You can fold it the other way and then use the crease to fold it back over, but we just want the grid to be on the inside eventually.
Yes. Yes.
Now, once you have folded it along the axes, you can tape those two things that had dots on them, the dashes on them, together to get a three-dimensional axis. What do you mean, what? Did I stutter? Did I speak Swahili?
Yes.
No.
Take a second.
Tape the two pieces together. Well, then process. Don't say what.
It's part of the process. Okay, well, no. No. It's good. No.
Why? Why? Oh, there we go. All right, we got it taped?
Yep.
I want you to put the X and Y axes sitting on the desk so the tape part's sticking up. Corbin, you need to get over there so you can be talking to your partner. X, Y part sitting on the desk, tape part sticking up. So here's what I want you to do now. And I'm going to want these magnets back. You can just use this as a little locator. I want you to find the place on your axes where X equals 2 and Y equals 4 and set that magnet on the place where X equals 2 and Y equals 4. I'm going to write it on the board. Here we go. X equals 2, Y equals 4, and set your little magnet right there on that spot. X equals 2 and Y equals 4. Bailey, how'd you get there? Where is X equals 2, Y equals 4 on that graph?
Go to.
Gonna go 2 this way?
No, other one.
Go 2 that way?
Yeah. I'm gonna go down one.
Do we agree that that's X equals 2, Y equals 4? Now, I want you to take that magnet and keeping X equals 2 and Y equals 4, make Z equals 3. What do you have to do with the magnet? And now, how would you write that point? If you wanted to write that point down, how could you designate the point where X equals 2, Y equals 4, Z equals 3? Discuss.
Why did you get rid of it? Now I can't see. No, you said I forgot. Like you said. I don't know. How you say?
Yeah, how could you label that point where X equals 2, Y equals 4, Z equals 3? Capon, what do you think?
I think it's so that things could be in the same place, but it's gonna be looked at 3.
Okay, and how are you going to write down where that point is on a piece of paper? You're just going to have to write X equals 2, Y equals 4, Z equals 3 every time?
2, 4, 3.
That was the question.
Guys, so far there's nothing new here, really, is there? we had a flat graph with an X and a Y, and we said, oh, well, let's just come out of the paper or up off the table to find the Z coordinate. And we have 2, 4 as the X and Y coordinates. And then we just said, oh, well, let's just stick another comma in there with a third number. And now we know where it is in 3 dimensions. Okay, I hope everybody's writing this down. Now, I want you to find the following point. 5, comma, -2, comma, -3. Where would you find that point? Oh no, the horror. So where would it be? Where would you find it?
This side.
Can you imagine?
Oh, look at that.
Oh. Go down.
Maybe like that.
All right, let's see what we got. Andrea, how am I going to get to 5, -2, -3?
Like this.
Can you describe to me what you're doing?
Okay, so we went past like this thing, this side right here.
What's this side called?
We went past the y-axis, to get to the negative y-axis. I know.
Well, I'm at 0 right now. Where do I need to go?
Five along the x-axis.
So 1, 2, 3, 4, 5. Now I'm way over here.
Yes.
Okay.
And then -2 on the y-axis,
So that's 2 this way.
and then lift your graph 3.
And then I got to go down here. So if I wanted to make a full coordinate system, how many of these would I need? Discuss with your partner. How many of these do I need for a full coordinate system?
It's not the same, man. You gotta put one on each other side.
Stand up on its own because
How many more? You have 4 quadrants on a regular graph, so you need 8. 7 more.
All right, let's see what we got. Bryce, what'd you guys come up with? 2? All right, here we go. I'm going to borrow Gwenny and Bailey's, and I'm going to make a complete coordinate system. Ready? Here we go. Here we go. There's my... Where do you want me to put it? Is it anywhere? There it is. Complete coordinate system. Covers the whole thing. I can graph every single point on that. Yes? Agreed, Bryce? Wait, did you say no? Why not? What else do I need, Bryce? Down here? So I need 4 of them? Okay, Bryce said now I need 4. First he said 2, but he realized, oh, yep, we need down here. So we're going to need 4 of them total. Right, Bryce? Why do you keep shrugging? Well, you're getting there. You're getting there. Savannah. 8. Well, Bryce has got 4. Where's the other 4?
On the back of it.
Oh, we need 4 more on the back, don't we? Because if we're going to go plus or minus x and plus or minus y, there's 4 right there. And then we need plus or minus z, which means we need another 4 to fill in the bottom or the back or wherever it is. So we're going to need a total of 8 of these things to go in every single direction. So instead of having 4 quadrants on a regular graph, we're doubling that, aren't we? We got 4 quadrants coming this way, plus we got 4 quadrants going that way for a total of 8 quadrants. All right, we cool with that? Thanks for the loan. All right. Let's play around with some 3D shapes. I need one person from each team come back. Grab a set of snap cubes. 1, 2, 3, 4, 5, 6. Here's what I want you to build. I want you to build a 2 by 2 by 2 cube, 1 vertex at the origin, and I want to know the coordinates of the furthest vertex from the origin. 2 by 2 by 2 cube, 1 vertex at the origin. I want to know the coordinates of the vertex furthest away from the origin.
Okay, that's cool. Yeah. This is the y-axis. Y-axis go up. We just stupid. Yeah, because it's like. So this is.
Jalen, where's the vertex furthest from the origin? Jalen says 2, 2, 2. Do we agree with that? Yeah, because you've got to go 2 in the X and 2 in the Y and then 2 in the Z to get to that furthest corner. All right. Okay, next one I want you to build. I want it to be 2 along the X, 1 along the Y, and 3 along the Z. And I want to know where the vertex is that's farthest from the origin. The question? You really want to answer the question? I'm going to pull somebody's name out in just a second.
Alvin? Oh, no.
No enthusiasm.
No, 1 Y up, 1 high. This is not high, this is just 3. Wait, what did we say?
All right, here's my first question for you. How many cubes did it take to build this, Savannah?
6.
6 cubes. And where's the vertex furthest from the origin?
2, 1, 3.
Agreed? And you use 6 cubes to make it. Okay, guys, don't take this one apart yet. Because what we're now going to do is we're going to draw this shape. But we are going to use something called isometric dot paper. Could you pass through those pieces back, please? I'm going to show you how to put the axes on this dot paper so that we can draw it in 3 dimensions. So here we go. Nope. Here we go. Come on. Oh, for Pete's sakes. Ridiculous. Absolutely ridiculous.
Technology.
I know. There's a button called blank. When you push the button called blank, it goes blank. When you push the button called blank again, it's supposed to come back. I think my remote's going bad. So here's how this works. We're going to draw the x-axis, pick some point, and draw the x-axis, or excuse me, we'll start with the z-axis. We're going to draw the z-axis straight up and down on the page, and then put a little z at the top to indicate that that's the z-axis. And then you're going to draw the x-axis down to the left at a diagonal. And then you're going to draw the y-axis down to the right at a diagonal. And what I'd like you to do is I'd like you to figure out how to draw that prism that you just built using those 6 cubes. Think about how you would draw that on this set of axes. Think about where your vertices are. Think about where your edges are. And go ahead and draw that, that shape that you've got. Okay? Go. Rather than hold, yeah, I'd put it on the axes, where it goes on the axes, Jack. It'll be easier to visualize. No, on the axes. Axes. Look, off to your right. There, boom, axes. David, how come you're playing with blocks instead of looking at them? And how come you don't have that on your set of axes so that you can draw it? There you go. What did I just tell you to do? I said draw that on those axes.
Oh, I see.
don't think you have to draw it. I do. Because it's harder.
So where are your axes?
Or yeah, kind of.
Where's the origin? So really X is here then, right? Because that would be Y equals 1 as opposed to the X axis. But otherwise, that's right. Well,
Now you gotta.
For what? What do they have to do?
bad night. Bad night. Try to get that. Okay. All right, I see lots and lots of good drawings. So here's the way I look at this. If I look at my shape, I see that there's an edge of a block, the bottom of a block right here and right here and right here, agreed? And then if I go up the sides of my shape, it's 3 tall and 3 tall, and then there's the top of a block right there. And then these blocks go backwards like that, a length of 2, and then there's the back of my shape, and then it goes straight down the side there. Do I need to fill in all those little cracks in the blocks? And I find it just actually makes it harder to visualize if you fill in all those extra things. Maybe you don't, and that's fine. But this is how I sort of like to do it. And then sometimes just for fun is I'll just, shade in one side just to make it really stand out and look a little bit three-dimensional there. Yeah, there's the front of my shape. You cool with that? Does that make sense? All right. Next. You're going to build a prism. Actually, let's do this. Why don't you guys jump into Google Classroom on your Chromebooks? And there is a worksheet called Classwork 3D Graphing. It's just material, not an assignment, but it is a classwork in your Chromebook. And if you scroll down to the second page, I take it back. If you scroll to the third page, we've done problems 1 through 4. Drawing this was the end of problem 4. So scroll down to the end of the page, the third page, and take a look at problem 5. And why don't you start working on that one for the next few minutes? Each team has at least one Chromebook? Yep. Okay, good. So start thinking about problem number 5.
Are we gonna use these things?
I don't know. What does it say? Problem number 5, first 4 words. Yes. Yeah. Sitting on the edge of that table right by my desk there.
Yeah, I'm pretty sure.
Well, let me go do it.
I'm pretty sure. And then four up.
Where?
Right here. It's just in front of the pasture.
Put that on it, what does it say?
That's just me saying.
That one you don't have to do. Just kind of move it around and think about it. Well, are we building it? Did ya? On your axes? Where does it go? So that's a rectangular prism? Uh-oh. It's closer than it was.
Three high.
The points are. I think she just.
Now, is that a rectangular prism?
Yes. Yes.
Probably not.
Well, I'll tell you that the last two are rectangular prisms. So what was different? Yeah, you need to fill it in. But nothing.
What?
And like, you'll feel like 2 seconds later, like, oh wait.
You build it?
No.
Oh, you drew it, said it?
Because I didn't have time for it.
Number 5?
She heard me.
I don't know why.
You're doing what? This isn't what my worksheet looks like at all.
When? Also.
Okay.
Yeah, you're gonna do it. This
All right.
I thought it may have been.
Wait, now it looks different.
I thought it may have been done now.
Oh, we're on day 1.
No, it's had that.
Sorry, the first 5. I didn't realize that happened.
Oh, good.
Oops.
We just put that down.
I don't think we presented, I think we just got one.
All right, guys. We're going to pause on this. I got an inequalities quiz for you. See what you learned about inequalities over the last couple of weeks. So here's what I want you to do. I want you to put all the cubes back into the little plastic bin. I got a Chromebook for her. No, I knew. I was watching. But yes, way to call her out into that. I'll take the magnets back.
I think we're
The scissors and tape could go away, and the bins of snap cubes will go on the table by my desk here, please. Magnet. 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 There. Thank you. And the little axes that you built could go on the back counter because we're going to use them again on Tuesday. We're going to keep talking about 3-dimensional graphing.
Please. I said, please. Thank you.
All right, you can have your toolkits out and nothing else. The quiz is open, informative, and there is a link in Google Classroom. Guys, no browsing around on the internet looking for answers, please. You're just doing the quiz. Looking at your toolkits if you want to, you don't have to. Not super complicated. I tried to make it pretty straightforward. So if you're paying attention, you should know how to do all the questions in it. All right. I'm going to run across the hall to talk to the pre-calc class. Mr. Brandon's going to wander over here, and I'll be back in a few minutes. Right next to my printer, there is a phone book. Were you making fun of my knot haircut? What? Were you making fun of my knot haircut? I'm gonna grow out like a long hair hippie.
Are you gonna do the mullet?
What's that?
You gonna do the mullet?
No. I'm doing the long hair hippie. Okay. Actually, so that you're aware, hippie is like a derogatory term. And technically, even though maybe none of you consider yourselves hippies, or I have nothing against hippies, it's really not appropriate term to use in school because it kind of puts people into a group and says, look at you. You know? You'd never get away with making generalizations about any group of people. I don't even want to say.
He made a typo.
Let me look. I might be able to tell maybe now. What did you say? It's okay. No, because you're just doing the one variable.
Oh.
You're just doing the one variable.
That makes sense.
Okay. And then do the numbers work out nice? Okay, the numbers work out nice, yeah. Yeah, we're supposed to do this quiz together. Yeah.
I couldn't get my thing to work.
Oh.
TGIF, folks. Have a good weekend.
Have a great weekend. Thank you.
Yeah, thank you.
Yeah, this is.
Andrea has found that if you fold it over and then turn it sideways, it's a lot easier to write on it. That's what she's found. If you're done with the quiz, you may work on homework.